this problem is to help walk through using the present value function and then also just solving this annual payment required to achieve the return, because we didn't really have a chance to go through it together in class. So I already filled in the beginning of the information, that is the equipment cost, life, annual savings, and our required rate of return. So we're going to just use the present value functions instead of NPV. And so what that looks like is that the present value today is the same as what it is. So we can just say equals negative equipment cost. That's our outflow. And then for the annual savings, we'll say equals PV, open parentheses. And so first it wants the rate, that's 20%, comma, the number of periods, which is 15 years, comma, the payment. And so since this is an annuity and it's the same for all 15 years, we can just go ahead and cell reference that inside of this one PV function and close our parentheses. And so then, sorry, we should have put a negative in front of this because we would prefer that it reports it as a positive. And then we can add those together. And so it currently today has a total NPV of negative 629,811. We can do that same thing using the NPV function. So we'll just lay it out across all 15 years this time. So a negative 2.5 million, annual cost savings of 400. I'm going to lock that in so that we can just fill right. And then we need to do the sum function to get our total cash flows. This part we did do in class together, so I'm just going quickly because this shouldn't be very unfamiliar to you. And then we can use the equals, NPV, open parentheses, all of our 15 years. Oops, sorry, I should have done rate first. I'm getting ahead of myself. Rate is 20%, comma, then all of our cash inflows, close parentheses, plus our outflow. So we get that same 629,000. What part 2 of this is asking is, what minimum dollar value per year must be provided by the equipment's intangible benefits to justify this 2.5 million investment? So in other words, these are the tangible benefits and the value of those actual flows of cash. But are there intangible benefits that we should consider? And so by working backwards to solve what that should be, that allows us as managers to say, are all of those intangible benefits worth at least X amount? And if they are, then we can go ahead and accept the investment. So for us to calculate this, we're going to say equals our current present value, and we're going to divide that by the present value. So you'll type PV, open parentheses, and then the rate is 20%, periods is 15, and in this case, the payment is at $1 because we're trying to figure out on the value of the dollar how much we would need to justify this current amount. So if we say equal or close parentheses, we get $134,705 per year. And so what this means is that of all of our intangible benefits, let's just pretend that it is happiness and improved quality and whatever else. As a manager, is that worth $134,000 per year? If it is not, then we still reject this project. If it is, if all of those intangible benefits can be justified for $134,000 a year, then we can go ahead and accept this project. So we're going to confirm that this new NPV would balance out to 0. So our initial investment is still the same, negative 2.5 million. I'm just going to reference this one. The annual cost savings would be the 400,000 plus the 134,000 that we're talking about, that we're saying would be the intangible benefit savings. And so we'll fill that to the right. Do another sum. Fill that to the right. And then use our NPV function equals NPV, open parentheses, rate of 20%, comma, all of our outflows, close parentheses, plus, sorry, all of our inflows plus our outflow, and that gives us 0. And so that confirms that if we have intangible benefits of $134,000 a year, making our annual cost savings $534,000 total, that we will have an NPV of 0. So we'll be at exactly the 20% return that was required.